Good morning everyone. I'm here to discuss about the syntax analysis focusing on the role of a parser. But first, let us know what is syntax analysis. Syntax analysis is needed to determine if the series of tokens given are appropriate in a given language. So the syntax analysis is the second phase after the lexical analyzer. Syntax analysis is also called parsing. For syntax analysis, context-free grammars, BNF, and the other associated parsing techniques are powerful enough to be used. So the bulk of this chapter is devoted to parsing methods that are typically used in compilers. I'll first present the basic concepts, then the different parsing methods. So let's begin with the parser. What is a parser? A parser is a compiler or interpreter component that breaks data into smaller elements for easy translation into another language. A parser takes input in the form of a sequence of tokens or program instructions and usually builds a data structure in the form of a parse tree or an abstract syntax tree. To understand more how does the parser works, try to look at this diagram. So in this process of compilation, the parser and the lexical analyzer work together. For the first, the source program will be read by the lexical analyzer as the lexemes. Then the parser will demand for the tokens and the lexical will supply the tokens that is needed. The parser collects sufficient number of tokens and builds the parse tree. Then, by building the parse tree, parse smartly fills the syntactical errors if any. It is also necessary that the parse tree should recover from commonly occurring errors so that the remaining tasks of the process input can be continued. If you don't understand the diagram, you may look at this list for the role of the parser. So let's go to the next topic. The next topic is the three general parsers for grammars. First is the universal parsing method, such as the CYK algorithm and Early's algorithm can parse any grammar. These methods are too inefficient to use in production compilers. Next is the commonly used methods in compilers are classified as the top-down parsing or bottom-up parsing. As the name itself, top-down parsers build parse trees from the top, which is the root, to the bottom, which is the leaves. Same goes to the bottom-up parsers. It builds parse trees from the leaves and work up to the root. So, take a look for this example. Top-down parsers uses backtracking. It tries to find the leftmost derivation. So, the top-down parsers start from the start symbol, which is the root node. And here is the input string. It will start with S from the production rules and will match its yield to the leftmost letter of the input, which is letter C. The very production of S, C, capital AD, matches with it. So the top-down parser advances to the next input letter, which is letter A. It does not match with the next input symbol, so the top-down parser backtracks to obtain the next production rule of A. So this is the backtracking. Then the parser matches all the input letters in an ordered manner. The string is now accepted. At the right, you can see the bottom-up parser. Read the productions in reverse. Bottom-up parsers reads the rightmost derivation. For more understanding, these parsing methods will be discussed in the next chapters. In both cases, input to the parser is scanned from left to right, one symbol at a time. Then the output of the parser is some representation of the parse tree for the stream of tokens. Programmers frequently write incorrect programs, and a good compiler should assist the compiler in identifying and locating errors. Few languages have been designed with error handling in mind. We know that programmers contain errors at many different levels. For example, first, the lexical error, such as misspelling an identifier, keyword, or an operator. An example for this is the number before the characters and the not variable and not a keyword either. Next is the syntactical error, such as an arithmetic expression with unbalanced parentheses. In this example, a equals to 5 plus 6, semicolon is missing, and printf hello has an unbalanced parentheses. Next is the semantic error, such as an operator applied to an incompatible operand. In this example, n3 equals to n1 multiplied by n2. n1 is an integer, n2 is a string, n3 is an integer also. Converting an integer into a string in an instant is not possible. Next is the logical error, such as an infinitely recursive call and the code not reachable. Example for these are the infinite loops. Much of the error detection and recovery in a compiler is centered around the syntax analysis phase. One reason for this is that many errors are syntactic in nature or are exposed when the stream of tokens coming from the lexical analyzer disobeys the grammatical rules. Error handler has a simple to state rules. First, it should report the presence of errors clearly and accurately. Of course, in any problem, the problem should be reported correctly. Next, it should recover from each error quickly enough to be able to detect the subsequent errors, so that the parser is able to check other error if any. It should not significantly slow down the processing of correct programs, because the correct programs are the most important. Here are the few questions that might help you to understand how does the error handling does. First, how should an error handler report the presence of an error? At the very least, it should report the place in the source program where an error is detected, because there is a good chance that the actual error occurred on the previous few tokens. Next, once an error is detected, how should the parser recover? As we shall see, there are a number of general strategies, but no one clearly dominates. In most cases, it is not adequate for the parser to quit after detecting the first error. There are many different general strategies that parser can employ to recover from a syntactical error. The error recovery strategies are used by the parser to recover from errors when it is detected. First is the panic mode and the phrase level. Panic mode recovery. Once an error is found, the parser intends to find the designated set of synchronizing tokens by discarding input symbols one at a time. The example of synchronizing tokens are the delimiters, semicolon, or the curly braces, whose role in the source program is to clear. When parser finds an error in the statement, it ignores the rest of the statement by not processing the input. This is the easiest way of error recovery. Next is the phrase level recovery. Parser performs local correction on the remaining input when an error is detected. Example for this is the local correction may be replacing a prefix by some string, replacing comma by a semicolon, and insert missing semicolon. The next error recovery is the error production and the global correction. Error production, which generate and constructs, are augmented to the grammar by considering common errors that occur. These productions detect the anticipated errors during parsing. The commonly made errors by the programmers are the semicolon is replaced by a comma. Next, the global correction. There are algorithms with changes to modify an incorrect string to a correct string. These algorithms perform minimal sequence of changes to obtain globally test cost correction. When a grammar G and an incorrect string is given, this algorithm finds parse tree for a string Q related top with a smaller number of transformations. The transformations may be insertions, deletions, and change of tokens. So that's it for the role of the parser. Thank you all for listening.